We are on to our last subject tonight, and it's actually about an asteroid that, well, it's a dangerous one. It's one that's been on our list for danger. To give you an idea about how big it is, there's the Hollywood sign that I put onto it. This is Bennu, but maybe it ought to be Bennu Wood instead of Hollywood on there. But Patrick is here to tell us what we've learned about Bennu. We visited it, obviously. You've got us a spacecraft there outside of it, and we've reported on this before, but what's the latest on this story about Bennu?
Okay, well, first of all, the spacecraft was a NASA spacecraft that visited the asteroid Bennu. It's called OSIRISRex, and it arrived at Bennu in December of 2018 and spent 3 years in orbit around this asteroid and do the photographic survey and also study the properties of this asteroid. Just to give you an idea of the scale, here's the observatory. This Katie's beautiful picture. And we're going to superimpose the size of Bennu. It's roughly about 6.5 times the width of the Griffith Observatory. The other parts of this particular mission was that the spacecraft has a sampling arm designed to do a touch and go of the surface. In other words, it will just gently glide down to the surface, and with its sampling arm, there was a blast of nitrogen gas, and it would just vacuum up some pieces of Bennu. It collected roughly about 60 grams, or about 2 ounces of Bennu off of its surface. Now, one of the recent things that came out of the data that we got from Bennu is, as David was saying, this asteroid is a near-Earth asteroid, meaning that it can, sometime in the future, will actually get close to Earth. There is a time frame for that, and in this graphic here, September 4th, 2135, this asteroid will be as close as half the distance between the Earth and the Moon. So it's just going to be in between the Earth and the Moon. At this distance, the Earth's gravitational field can affect its orbit and change its trajectory. This is one of the things that scientists wanted to calculate, is what changes will happen when this happens. What OSIRIS-REx has done is that it's allowed scientists to refine Bennu's orbit and allow it to better model the potential of impact with the Earth. Now, in this case, in 2135, there is no impact. So that's good news. Where that question mark is a region of space, and it's represented by all these keyholes, which scientists kind of label it as the gravitational keyholes. If the asteroid passed through any of those keyholes, the potential of impact would be much greater, so the probability goes up. If it's outside, it will be less probable. There is another effect that can alter the trajectory of Bennu, and it's not just gravitational. It's something called the Yarokovsky Effect. And this effect is basically kind of similar to what Chris was talking about. This is the natural heating of the daylight side of the asteroid. And in the case of Bennu, Bennu does rotate. So when the asteroid rotates to the night side, the heat is re-emitted from the night side of the asteroid. As it cools, this will give the asteroid a slight nudge, a gentle push on the asteroid. Now, for Bennu, scientists have calculated from the data from OSIRIS-Rex that this force is equivalent to the weight of 3 grapes. Now, you might think, well, just 3 grapes, that's not much. But over time, and we're talking about tens of years, this effect can be significant, and it will build so much so that this Yarokovsky effect will alter or perturb the orbit of Bennu. And so what kind of data was gathered in order for scientists to calculate this effect? Well, they needed to know the size, the mass, the shape, the rotation state, and the surface and thermal properties of this asteroid. And this is something that is very difficult to get from ground-based observations, but OSIRIS-Rex got all of this data during its 3-year mission. And all of this data enabled the scientists to actually calculate and factor in this Yarokovsky effect into the trajectory models that they had. The original estimate was that there was a potential for impact further down the line in 2182, but with the data that was observed from OSIRIS-Rex, they were able to refine the probability by a factor of 20-fold. They now have an estimate that the impact probability of Bennu crashing into the Earth is 1 in 2,700, or about 0.037%, which is minuscule. Now, one thing is for sure, the OSIRIS-Rex spacecraft is returning to Earth, and in September of 2023, this little capsule, there it goes, containing a little piece of Bennu, it's a sample return capsule, will end up with a thump in the deserts of Utah. Probability of impact is close to 100%, but we'll have Bennu crashing into the Earth inside a capsule. Yeah.
A tiny, tiny piece of Bennu, it's going to come crashing down with 100%, well, nearly, as Patrick said.
Yeah.
But it could go a little wrong. Well, folks, with that, we can all rest easy with that good news that 161-ish years from now, we have a very small chance of being hit by Bennu. I was being kept up at night by that concern. But in any case, it's interesting being able to measure these details and knowing what sort of things you need to worry about. People often think, why can't we just see where it's going, know its orbit? Once you have it calculated, you know it pretty well. Well, the answer is we don't. Things can change. They can get nudged by other objects, and even the very sunlight falling upon the object can cause it to deviate where it's going. Objects can spin up too. Sunlight can spin the objects up. It's super cool.